Hi everyone, it's Mrs. Cook. We're going to start Chapter 13B today, Honors Advanced Algebra, Section 13.2 in your notes. These are notes day 1. Some of you were absent in class today, so I'm hoping that this video will help you. There are 4 learning targets today. The first one is to draw and find angles in standard position. So let's take a look at these angles here. We call these angles in standard position because they have a vertex that is at the origin. So the first thing is to notice that their vertex is at the origin. The next thing to note is that they have an initial ray. Now to me, initial means start. Does initial mean start to you? So this ray is where the angle starts. There's an initial ray always along the positive x-axis. And then the angle is going to rotate. Now to create a positive angle, we're going to rotate counterclockwise. And we do that through our quadrants. I'm hoping that you remember from algebra that this is my first quadrant. So where I have a positive x and a positive y, that's quadrant 1. And then moving to the left here, this is quadrant 2. And moving downwards, quadrant 3. And over to the right is quadrant 4. So as I rotate through the quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4, that's the direction that I'm going to create my angles in. If I rotate the other direction, for example here in this second diagram, I have rotated backwards now through the quadrants, so that is a rotation of a negative angle, negative 145. As I need to draw angles on my own then, let's go ahead and start with some coordinate planes. So all of these need a quick little sketch of a coordinate plane, and they all need an initial ray. So I'm going to go ahead and construct an initial ray. Initial means beginning. So my initial ray goes this way for all of these. Now I need a terminal ray. Terminal rays are the rays that rotate and then they terminate or they stop at some point. So this terminal ray needs to rotate through the quadrants 65 degrees. So that's going to be a counterclockwise rotation of about 65 degrees, something like this, creating this angle in standard position. On this one, negative 120 degrees. So my terminal ray is going to rotate, but this time it's going to rotate backwards through the quadrants, coming down into quadrant 4 and ending here in quadrant 3. So this is an angle of negative 120 degrees. Notice I'm drawing my rotation. It's very important that we draw that rotation there with the arrow at the end. On this one, my terminal ray gets to have some fun. It's going to go around the circle more than once. Take a look. This time, it's going to rotate one full time around the circle. That's 360 degrees, but it needs to go in another 30 degrees. So this snail-looking rotation here is 390 degrees. And this terminal ray, you can tell it went all the way around one time and then up a little bit more. That's the first learning target, drawing angles in standard position. The second learning target deals with coterminal angles. So if I'm looking at what a coterminal angle is, it says angles in standard position that have the same terminal side are called coterminal angles. Co means they share, terminal, they share the terminal ray. So they share the terminal ray. Coterminal angles always differ by a multiple of 360. So I'm going to highlight there that. You should too in your notes. They always differ by a multiple of 360. Let's take a look why. On this example, we need to name 4 angles, 2 positive and 2 negative, that are coterminal with a 55-degree angle. So let's go ahead and sketch that. I need my axes, and I'm going to have an initial ray here along that positive x-axis. Now, 55 degrees is a rotation counterclockwise into quadrant 1 here, something like this, 55 degrees. If I did not show you this rotation, so let me actually, oops, didn't mean to do that. Hold on a moment. Undo. Let's see if it'll let me just erase this arrow here. Oh, bummer. Something's going on. I was going to erase this arrow here to show you that if I don't have the arrow, you can't tell which way I've rotated to create my terminal ray. So for example, we're not sure if I don't put this arrow here, had I gone around this direction and created this angle. Or maybe I went around the quadrants one full time and ended here. So it's very important that we put this directional kind of arrow. All of these angles, this blue one, this green one, these are all coterminal because they share this terminal ray with the 55-degree angle. You can see they differ by 360 that I highlighted here. So in order to algebraically do this, we would just take our 55-degree angle and add 360 degrees to that. And that will get us our 415 degrees. Okay, taking a look then at another positive angle, I can say, well, from 415, let's add another 360 to that. Let's go around the circle one more time. So that's 775 degrees. There are two positive angles that are coterminal. You could have also said, let's start with 55 and add 720 because 720 is two rotations. So I know some people in class were doing it that way. To get the two negative here, let's go ahead and do those. I'm going to start with 55 degrees, but this time I'm going to rotate the other way around the circle. So I'm going to subtract 360 degrees. And this is how I get my negative 305 degrees as another coterminal angle. So that would be my blue angle here that I've created. And I could subtract 360 again, go around, create another coterminal angle, negative 665. So that is our second learning target, which is to understand coterminal angles, that they share that terminal ray. Moving on to the third learning target, we have to review some geometry. In this case, I've created a unit circle. A unit circle has a radius equal to 1. So you can see with all these ordered pairs here that the radius is equal to 1. Now, it says the unit circle is centered at the origin whose radius is 1 unit long. Form an angle in standard position so that the rays of the angle intercept an arc 1 unit long. So if I were to try to take this piece right here, this same length, and lie it along the circle, it would create a distance something like that. So I took this guy and I laid it along the circle. It would create something right around there. What I've done is I've created this angle here, theta, and theta is by definition 1 radian. Okay, now let's take another look at this unit circle. In geometry, you learn about circumference of a circle. You learn that the circumference of a circle is 2 pi r, or pi d. The radius of my circle is 1, so let's go ahead and pop that in here. 2 times pi times 1. And I can see that the circumference, if I were to walk around this entire unit circle, the circumference would be 2 pi. And that's about 6.28 or so. So walking all the way around the circle, take a look. There would be 6.28 of these red pieces. So 6.28 radians. 1 radian, another would get me to about here, another to about here. And going all the way around, I'd have about 6.28 of those red arcs. Now, you talk about arc length in geometry, so if I'm just going from A to B, I would say, oh, just from A to B is 1/4 of the whole circle. Just from A to B is 1/4 of my 2 pi. It's 1/4 of the whole circle. So now I can cross-reduce and see that that is going to be pi over 2. And pi over 2 is approximately 1.57. So taking a look. If I look at this red piece, there's enough room up to B for 1 of these and an additional little bit more than 1/2 if I were to have drawn that accurately. How about just from A to C? If I just go from A to C is half of my circle, so it's half of my 2 pi. And so I can see that I can cross reduce, and I get pi. So just from A to C is pi radians, and that is about 3.14. And finally, talking about arc length in geometry, if I go from A all the way around here to D, that's 3/4 of my circle. So that's 3/4 of my 2 pi, which I can cross reduce. And I get 3 pi over 2. And that's approximately 4.71. Okay, so the important thing, what I want you to get out of this whole exercise from geometry is that one full time around the circle, 360 degrees, is now defined as 2 pi. So 360 degrees is 2 pi radians. Or, and I apologize, this got cut off of your notes, so let's get rid of that or there. We'll make a better, bigger note down here. Or the key to this learning target is to realize that 180 degrees, so half of a rotation around the circle, is now defined as pi radians. And in your notes, I advised you guys in class today to kind of put a loop around it, put some stars around it. You definitely want to know this to be good at going from degrees to radians and vice versa. So let's practice that third learning target here. Let's take a look at doing some conversions. Now it says we're going to convert between degrees and radians by either multiplying by pi over 180 or 180 over pi. In these first examples, I want to convert from degrees to radians. So I'm given degrees, and I'm therefore going to put 180 degrees down here. This is similar to how you think in terms of unit conversions in a science class. We want our units to cancel each other out, so I'm going to put 180 degrees in the denominator. Now 180 degrees is pi radians. So you can see I'm multiplying by pi over 180, which is exactly what this told me to do here. Let's do some reducing. 30 goes into 180 6 times, so I get pi over 6. Notice I'm not writing radians because in terms of an angle, if I don't write the units, it's automatically written in terms of radians. We read it that way, so you don't have to write radians. So I would encourage you now to go ahead and multiply each of these by pi over 180. See how your degrees cancel, and then your numbers can reduce to get pi over 4 in this case, and so on. So as you do that, go ahead and pause the video, try these two now, and come on back and check your answers. So when you come back, you should get pi over 3, and this one you should get 2 pi over 3. Okay, taking a look here at example 4, let's go the other way now. So if I'm going to convert 0.1, now remember this is in terms of radians, given to me in radians. They don't have to write radians, but that's what we have here. So I'm going to multiply then, I want radians to cancel, so let's put pi radians in the denominator. Pi radians in the denominator. And pi radians is 180 degrees. So you can see I'm following this little piece of advice right here, multiplying by 180 degrees over pi radians. My radians cancel, and I know that 0.1 times 180 is 18 degrees, so I will get 18 over pi degrees. Definitely need to write my degree symbol, otherwise I think it's radians. Notice it says answer in terms of pi if applicable, so I'm just going to leave 18 over pi. You could take out a calculator and divide 18 by pi if it asked you to do so. So each of these now I'd like you to go through and practice, multiply by 180 over pi, and make sure you can get those correct. Here I would have 1800 over pi, and again I can leave it in terms of radians since it says to do so, otherwise I would go ahead and divide. Multiply here in terms of, or by 180 over pi, and each of these, pause the video and then come on back. So when you come back to me, you multiplied each of these by 180 over pi, and these, your pi's cancel. You can see that if I multiply by 180 degrees over pi, that the pi's do cancel, and then my 3 went in 180 times. So I got 480 degrees. And if you did this one correctly, then you get negative 30 degrees. Negative 30 degrees. Think about what that looks like now. From our first learning target, you know that a negative 30 degree rotation has an initial right here and rotates backwards into quadrant 4. So this would be a negative 30 degree angle, which is a negative pi over 6. Okay, finally, we are at our fourth learning target, and this is to understand the unit circle. So as I take a look, we have some things that we just learned. We learned that 180 degrees is pi radians. So if I'm converting here, I can say 180 degrees is pi radians. I can say 360 degrees all the way around the circle is 2 pi radians. So this would be 0 radians or 2 pi radians. Now, if I go up to 90 degrees, I can do what I was doing up here in these problems in example 3, and I could go ahead and I could multiply each of these by pi over 180, pi over 180, pi over 180. But look at how tedious that would be. We need to know these angles. These angles are all built on our special right triangles, 30, 60, 90, and 45, 45, 90. So we're going to see them so much, let's get good at this. So instead of multiplying by pi over 180, I want to think conceptually. 180 degrees is pi, so 90 degrees would be half of that. This is a pi over 2. Now as I count around my circle, the step here is 1 pi over 2. This guy would be 2 pi over 2, which has been reduced. So down here I have 3 pi over 2. Think to yourself, what is 3 over 2? Well, 3 over 2 is 1 1/2. So look, we have 1 pi and another half of a pi. And then I could step here to get 4 pi over 2, which was already reduced to 2 pi. Let's try it again for our 45 degree steps. So if I'm stepping 45 degrees, so how many 45 degree steps are there in 180 degrees? Well, you can see that there are 4 of those steps. So 45 degrees is pi over 4. Now let's walk around the circle, stepping 45 degrees. This is 1 pi over 4. 2 pi over 4, okay, already reduced. 3 pi over 4. Pause and make sure this makes sense. Is this looking like 3/4 of the way to my pi? Yes, it is. So 3 pi over 4. 4 pi over 4. Down here I have 5 pi over 4. Stepping another 45 degrees, I have 6 pi over 4. So this guy would be 7 pi over 4. Again, 7 over 4 is 1 3/4. So look, 1 3/4 of the way through around the circle. And then this would be 8 pi over 4, which has already been reduced. Now next up, I like to step my 30 degree steps because 30 degrees are going to take care of my 60 degree steps. So just to get around there a little bit quicker, let's step 30 degrees. In 180 degrees right here, there are 6 30 degree steps. So a 30 degree step would be a pi over 6. Now this is 1 pi over 6, so another one would be 2 pi over 6. Let's just reduce that to a pi over 3. This is 2 pi over 6, so here we have 3 pi over 6, already reduced. 4 pi over 6, so let's reduce to 2 pi over 3, or 2/3 of the way to pi. I'm now at 5 pi over 6, 5/6 of the way to pi. 6 pi over 6, 7 pi over 6. 8 pi over 6, which I can reduce to 4 pi over 3. 9 pi over 6, already reduced. 10 pi over 6, which is 5 pi over 3. And 11 pi over 6 right here. Take a look. 11 over 6 is indeed 1 5/6. So that's 1 pi and another 5/6 of a pi. And finally, 12 pi over 6, which was already reduced. So this is how I want you to create your unit circle, by stepping around the circle. And eventually, if I ask you what's 225 degrees, ooh, do I have that wrong? I hope you caught that and you're shouting at the video right now. Let me count again. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Were you shouting at me? I hope so. Let's fix that guy. 5 pi over 4. Yes, 1 1/4. 1 1/4. So if I say, what is 225? You can all tell me without thinking too much, hey, that's 5 pi over 4. That's where we are headed this chapter. If I say, what is 60 degrees? You say that's pi over 3. So we need to get really good at this unit circle. Okay, so finally, here they just want me to practice. 91 degrees, have you put together these learning targets. A 91-degree rotation would look something like this. So that would be end in quadrant 2. 7 pi over 3, well, my brain thinks, well, 7 over 3 is 2 1/3. So let's go 2 pi, which is 1 full circle, and then 1/3 of a pi to land in quadrant 1. And down here, they want me to determine whether they're coterminal. So I want to know, do they differ by 360? So can I add 360 to get to the next angle? Do they differ by 360? No, these guys do not. Do they differ by 360? But wait, let's have our brains thinking in terms of radians. Do they differ by multiples of 2 pi? Yes, I can add 2 pi 4 times to get to 8 pi. So this is a yes. Okay, do these differ by 360? Do these differ by 2 pi or 360? Well, let me actually test this one. 33 pi over 8 minus a pi over 8 is 32 pi over 8. Oh yeah, that is 4 pi. So they do differ by 2 rotations around the circle. This would be yes. Give it a try now on your own. Go ahead and work through assignment number 1 right here, and we will practice more of these tomorrow. Thanks for joining me.